Imagine this. You have a solid ball, like a snooker ball. Now imagine cutting this ball into a few pieces. Not slices, mind you, but very specific, oddly shaped pieces. Here's the kicker. You can take these pieces, reassemble them, and end up with two identical snooker balls. Sounds impossible, right? That's the Benach Taraski Paradox for you. This isn't your everyday magic trick. It's a mind-boggling mathematical theorem that throws everything we thought we knew about reality out the window. It makes us question, can something truly be created from nothing? The Benach Taraski Paradox, named after mathematicians Stefan Benach and Alfred Tarski, is a testament to the weird and wonderful world of mathematics. It's a world where logic reigns supreme, even if it leads to seemingly nonsensical conclusions. So buckle up and get ready to explore one of the most fascinating and counterintuitive ideas in mathematics. The Benach Taraski Paradox was first proposed in 1924 by, you guessed it, Stefan Benach and Alfred Tarski. These two Polish mathematicians were no strangers to pushing the boundaries of mathematical thought. Benach, known for his work in functional analysis, and Tarski, a logician and mathematician, collaborated on this theorem that would cement their names in the annals of mathematical history. Their work was built on the foundations laid by earlier mathematicians like Georg Cantor and his work on set theory. Their discovery wasn't just a mathematical curiosity, it had profound implications. It challenged the very axioms upon which mathematics is built. It made mathematicians and philosophers alike reevaluate what it means for something to be true in the realm of mathematics. Let's try to understand this perplexing paradox. The Benach Taraski Paradox states that you can take a solid ball in three-dimensional space, cut it into a finite number of pieces, and then reassemble those pieces to form two identical copies of the original ball. Now, before you start searching for your geometry box, there's a catch. These cuts aren't your regular straight lines, they are incredibly complex, infinitely intricate cuts that are impossible to make in the real world. Think of it like this. You have a cake. You cut it in a very specific way and reassemble the pieces. Suddenly, you have two cakes. It seems impossible, but the Benach Taraski Paradox tells us that in the realm of mathematics it's entirely plausible. At the heart of the Benach Taraski Paradox lies a controversial mathematical principle, the axiom of choice. This axiom states that given any collection of sets, each containing at least one element, there exists a function that can choose exactly one element from each set. Seems harmless enough, right? Well, the axiom of choice has some bizarre consequences, the Benach Taraski Paradox being one of them. It allows for the existence of non-measurable sets, which are sets so complex that it's impossible to assign them a volume in the traditional sense. These non-measurable sets are the key to the Benach Taraski Paradox. The specific pieces you cut the ball into are non-measurable sets, which means they don't obey our usual rules of volume and measurement. The axiom of choice is a bit like a mathematical get-out-of-jail-free card. It allows mathematicians to make certain assumptions that lead to fascinating, albeit sometimes counterintuitive results. Here's where the Benach Taraski Paradox really starts to mess with our minds. It seems to violate a fundamental law of physics, the conservation of mass. This law states that mass cannot be created or destroyed, only transformed from one form to another. So how can we reconcile the Benach Taraski Paradox with this fundamental law? The answer lies in understanding that this paradox is a mathematical concept, not a physical one. The Benach Taraski Paradox doesn't imply that we can magically create matter. Rather, it highlights the limitations of applying mathematical concepts to the real world. It tells us that while mathematics can be a powerful tool for understanding the universe, it doesn't always perfectly reflect physical reality. The Benach Taraski Paradox is undeniably difficult to grasp. How can something be divided and reassembled to create more of itself? It's a concept that seems to defy logic and intuition. One way to think about it is to imagine a line segment. You can divide this line segment into an infinite number of points. Now, imagine rearranging these points and creating two line segments, each identical to the original. While this is a simplified analogy, it illustrates how our usual understanding of size and measurement doesn't always apply in the realm of infinity and non-measurable sets. The Benach Taraski Paradox, in a way, reveals the limits of our intuition when dealing with the infinite. The Benach Taraski Paradox is just one example of the many mind-bending paradoxes that populate the world of mathematics. Paradoxes like this highlight the beauty and strangeness of mathematical exploration. They remind us that even in a field governed by logic, there's always room for surprise and wonder. These paradoxes force us to confront the limits of our understanding and to approach problems from new and creative angles. They remind us that the pursuit of knowledge is an ongoing journey, full of unexpected twists and turns. The Benach Taraski Paradox, while initially perplexing, ultimately enriches our understanding of mathematics and its relationship to the world around us. The Benach Taraski Paradox is a fascinating example of how mathematics can challenge our perception of reality. It's a reminder that the universe is full of wonders, and that the pursuit of knowledge is an endless adventure. If you found this exploration of the Benach Taraski Paradox intriguing, then subscribe to our channel for more mind-bending mathematical concepts, thought-provoking discussions, and fascinating explorations into the world of science and mathematics.